In this lesson, you will learn how to solve radical equations. Let's take a look at an example to better understand this concept. This is a radical equation because it has a radical symbol in it, which is simply a square root sign. So what you are trying to do is trying to figure out the value or values of x so that the square root of that number will equal 6. So you need to go back to thinking about perfect squares, remembering that 1 squared is 1, 2 squared is 4, 3 squared is 9, etc. So let me write down the first 6. Now remember, squaring a number is the opposite of taking its square root. So if you take the number on the left side, on the right side and put a square root symbol around it, then it should equal the number that's being squared. So the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, 16 is 4, 25 is 5, and square root of 36 is 6. So for this particular problem, you're trying to figure out what number would you have to take the square root of in order to get 6 for an answer. And if you look over to the right, you can see that you would have to take the square root of 36 to get 6. So our missing number is 36. Another way to approach this is because taking the square root of a number is the opposite of squaring a number, you can actually eliminate the square root symbol from the left side by squaring it. Now, of course, to keep the equation balanced, you need to square both sides. So whatever you do to the left, you do to the right. So a square root sign cancels out the square root symbol, leaving you with only what's underneath the square root symbol, which would be the x. And then to the right, the 6 squared, 6 times 6, would give you 36. So this is a different way to figure out what the value of x should be. Now let's add some components to these equations and figure out x as well. So in this problem, it says 5 times the square root of what number equals 25. So this is just not as simple as saying the square root of what number is 25. The first thing we must do is isolate the radical on the left side of the equal sign, just like you would if you had the equation 5x equals 25. So in this equation, if you were to isolate the x, you simply divide by 5, and x would be 5. In this radical equation, in the same way, to isolate the radical, because the 5 is being multiplied by the radical, you're going to divide it and move it over to the right. Eliminating the 5 from the left, so you only have radical x, and then 25 divided by 5 is 5. So now this looks similar to the last problem we did. We're simply trying to figure out what number, if we take the square root of it, would give us an answer of 5. Remembering our perfect squares, we change that to a 9, square root of 9, square root of 16, we'll stop at the square root of 25. If you look over to the right, you can see that when you're trying to figure out what number would you have to take the square root of to get 5, it's going to be 25. So x is 25. And again, the other way to do it is to square both sides, because the squared symbol eliminates the square root symbol, so you only have what's left under the radical, and then 5 squared is 25. Let's look at the next problem. Now in this problem, notice the radical symbol and what's underneath it is already isolated. There's nothing else outside of it on the left side of the equal sign. So we're going to immediately want to remove that radical symbol, and to do that, we need to square both sides of the equation. So remember, squaring it removes the symbol, but does nothing to what's underneath. So that simply drops down. On the right side, we will calculate 5 squared, which will give us 25. So now we simply have a linear equation to solve. And when we solve this, we know what x will need to be. So we're going to isolate the x by subtracting 1. That will leave us with 4x equals 24. Then we will divide by 4 and the value of x turns out to be 6. Now over to the side here, let's double check. So let's copy down our original radical equation, radical of 4x plus 1 equals 5, and let's prove that our answer truly is 6 by plugging the 6 back in for x. So in place of the x, we're going to put 6, just to double check it, and we're going to calculate the left side of the equal sign and see if it comes out to 5. So under the radical, 4 times 6 is 24, plus 1 gives us radical 25. And since the square root of 25 is 5, we've just confirmed that our answer for x is correct. The answer is 6. Let's take a look at an additional problem. Here we have 3 times radical x equals 2. So once again, we want to go ahead and isolate our radical. And since the 3 is being multiplied by the radical, we're going to divide it on both sides. This leaves us with radical x equals 2/3. Now this one is probably, for some of you, not as obvious, something you might not be able to do in your head, so you might want to go ahead and square both sides to figure out the answer. So on the left, our squared symbol cancels our radical symbol, leaving us with x. When we square the fraction, what we do is we actually square the numerator and we square the denominator, which will give us 4/9 for x. Now over to the right, I'm going to double check that. So I'm going to write 3 radical x equals 2. And I'm going to replace the x with 4/9 because we feel that it should be 4/9. So let's check. So on the left, if I take the square root of 4/9, so because 4 is a perfect square and 9 is a perfect square, I can take their square roots individually. So I'm going to keep the 3 on the outside. The square root of 4 is 2, and the square root of 9 is 3. And if I multiply those fractions and even cross-cancel the 3's, notice I'm left with 2, which is what I wanted. So in fact, my value for x, which is 4/9, is correct. Let's take a look at the next problem. Here we have radical 2x minus 1 plus 7 equals 10. If you look at the left side of the equal sign, notice the radical portion is not isolated because there is a number outside of the radical, which is the 7. So we first need to move that to the right to isolate the radical. Because it's being added to the radical, we're going to subtract it in order to remove it. This will leave us with just the radical. On the right, 10 minus 7 is 3. Now we want to remove the radical symbol by squaring both sides. So the squared symbol will cancel out the radical symbol, but it will have no effect on what's under the radical. So we'll be left with 2x minus 1. On the right, 3 squared equals 9. Now we simply need to solve our equation. So to isolate the x, we will first add 1, then we will divide 2. So x equals 5. Now let's prove that over to our right by rewriting our radical equation. Let's replace the x with 5. Okay, so we just substituted in the 5 for the x. Now we're going to simplify the left side and see if it comes out to 10. So we would have 10, because 2 times 5 is 10, minus 1 under the radical, and plus 7 outside the radical. 10 minus 1 is 9, so we have radical 9 plus 7. Radical 9 is 3 because it's a perfect square, and 3 plus 7 does in fact equal 10. So our answer checks out. Okay, let's take a look at one more. Now this one is a little more confusing because of the location of the radical. We have both a 5 and a 3 outside the radical, which you cannot add together because 3 is actually part of radical y. And because it's not a like term with a 5, because in order to be a like term they have to have matching radicals, you cannot add the 5 and 3 together. So what you're going to do to isolate the radical, think about it like an equation. So let me write over here without the radical what it would look like as just a linear equation. Now, of course, these two could be reversed, and sometimes that helps when deciding what to move first if you're isolating a variable. And here we would subtract the 5 and then divide 3 if this were a linear equation. We're going to try this a similar method with this radical equation. Now, the first thing you might want to do is move the 5 to the right of the y. In other words, the 3 radical y, instead of having the 5 at the beginning, and it's a positive 5, we'll just have it right after. So we'll put plus 5. So now it looks a little more similar to our linear equation. So we're going to isolate the radical first by subtracting 5 to get our constants together, which are our numbers without variables. So 17 minus 5 is 12. We will finish isolating the radical by dividing the 3. So now we just need to figure out the square root of what number equals 4. And if you can't figure it out in your head, go ahead and square both sides so you can eliminate the radical, leaving us with just the y. And then on the right, 4 squared is 16. So our missing variable should be 16. Now we're going to go ahead and prove that to the right here. We're going to plug the 16 back in for the y and see if it works. So that would give us 5 plus 3. I'm going to put radical 16. I'll put the 16 in red so you can see what I substituted in. Now, the square root of 16 is 4, so that's the first thing you must do is change that to a 4. Now, once again, you cannot add 5 and 3 because you must follow the order of operations in which multiplying comes first. So 3 times 4 is 12, so we'll have 5 plus 12, and that does in fact equal 17, so our answer checks out. And that completes the lesson on solving radical equations. Good luck.